All right, so we have reached the end of Unit 4, and this is Unit 4, Lesson 8, and it's pretty much a culmination of everything we've learned. Um, what they're trying to get us to do is showing us the two polygons, and they want us to write the algebraic descriptions and um, the written descriptions of what it's going to take to map these two congruent shapes over top of each other. There's a couple. This is derived from the homework of lesson 8, but the practice work is pretty similar to what the homework is. I'm zooming in so you can see the numbers easier. Okay, so a couple ways you can do this. This one is just one algebraic move or one transformation. You can take some patty paper, some more electronic patty paper here, and you can copy your first one. Right, I'm going to move it over here so it doesn't do any crazy glitches, right? And then I'm gonna go ahead and I'm gonna rotate this thing, and you can see that if I rotate it 180 degrees, it's pointing in the same direction. The orientation has changed such that it would map over itself. Is this yeah, even if it's transparent, you can't really see it, right? But you can see that it would map. It's pointing in the same direction. So that's a 180-degree transformation, right? So the algebraic description or the written description is, I gotta make that bigger so you can actually see. Let's do it like 36. How about a 48? This is a 180 degree rotation. Rotation. It's about rotation about the axis. About the axis, right? And if you don't remember how to derive or don't remember the algebraic description of that, you can pull 2 points that don't share the same absolute value, like T and B would not be a good value, but they have to be corresponding points. So the pointy end would probably be a good one, pretty obvious, P and R. So I'm gonna take I'm gonna call this one red. I'll call this one P. We'll call this one blue. Right, so the red point here is we'll call it R, as it is, and this one is -2 comma -6, -2 comma -6, -2 comma -6, right? And then the other one, blue one here is 6 comma 2, 2 comma 6, 2 comma 6, and then you're like, okay, well, blue in terms of red. Right, well, what changed? Well, my blue term is the same as my red term, so the x's are the same, but the sign changed. Okay, same thing as my y's. Y's are the same absolute value, but they change. So this is the back end of your transformation or your algebraic description. Front end is always the same, x comma y, pulled from -x, -y of your original point. All right, so that is number 1. That's how you do number 1 of the homework. They give it to you in answer form, like the answers are in like table format, but I don't want to do that. I want to be able to read the tables, the units on the tables better. Otherwise, you can leave more mistakes. All right, so the next one, this one's going to have two transformations on it. Okay, so the next one here, well, again, how can I figure out, I could visually in my mind, I need to change the orientation of this triangle or map it onto this triangle, right? We'll go triangle, this is triangle blue, make my triangle blue, right? Make it really big. Triangle blue here, right? And I have my triangle red here. I want to map triangle blue on triangle red. I'm not 100% certain that the points are all lined up. I'm just gonna make sure that I figure that out on my own. But how would I reorient this to to do? Do I have to do a rotation one way? Do I have to do a translation one way? But I definitely need to reorient this a certain way in order for it to line up. Okay, well, let's see what happens if I take my electronic patty paper here, throw copy, move it over there that way. What happens if I rotate this thing to the right? Well, that doesn't do it. And then we'll see what happens. I rotate it. I rotate it to the left. Oh, look at that. That looks like it would overlap pretty good. That will overlap pretty good. So that's a left. That is a, if I rotate it to the left, that is a counterclockwise rotation. Counterclockwise rotation. So, and then I'm gonna have to move it probably. So what does a counterclockwise rotation look like? Well, the X, gonna go X, Y is gonna be probably from, move this up a little, I guess. It's gonna be pulled from okay, X, and then I know for a rotation, the X's and the Y's, X comma Y, they're supposed to flop. Y, X, and for a counterclockwise rotation, means go from here to here, here to here, that the negative sign changes. So from counterclockwise rotation, the negative sign rotates. So, all right. So, so how we gotta figure out what the coordinates are, and then we'll plot it there from there. So I need to figure out. I'll go, T, G, and R. My T coordinates -2, -2, -2, -2. My R coordinates -2, -6, -2, and -6. And then my G coordinates -4 and -3. -4 and -3. Okay, I'll go to a green, my intermediate one. So I'll go to green. My X, Y coordinates, if I shift from these, could be -Y, -X, -YX. So my Y's, my X, my new X coordinates going to be the opposite of my Y's. So that's going to be 2, 6, and 3. My Y coordinates can be the same as my old X. So it's -2, -2, -4. I'll plot these. So I'm going to go 2. I'm going to go 2 and then -2. And then I'm going to go 6 and -2. And then I'm going to go 3, 3 and -4. Like my straight line drawer. There. Okay, now I got to figure out how much I need to translate, go over from one point to the other. And I'll use red for this one. Okay, so now I can kind of figure out that this point here is 2, -2. This is going to be my T. This is going to end up being my B. And then this G is going to end up being Z. And then this P, this R is going to end up being this P. Okay, so my final minus initial, right? So I could just count coordinates. That'll probably be easier since they're pretty close. Or I can go my final. Oh, this is a pretty easy one to go off of. Z. My final X, final Y, delta equals final minus initial. They're both final Y minus initial X and initial Y equals, they're both 0 for the final. And then I'm going off of Z here. And then for here, my initial is going to be -3, right? And then -4, minus -4. So this is going to be -3 and then +4. Right, so there we go. And that's my delta X, my delta Y. All right, so my equation for this one is going to be X. I'll put it up here, I guess. X comma Y, or X comma Y, pull from X -3 comma X +4 and then if I have another column over here to the right, I'm just going to say this was a rotation counterclockwise about the origin by 90 degrees. Then translation of 3 units to the left, which is negative, and 4 units up, which is positive. All right, so that's how you do both the algebraic and so these are my answers here. So this is one of the answers there, and the other answer is right there. And the rest is the work to do it. So there you go. That's how you do that one. So, all right. Moving on to the next one. Guess I'll do one more of this. Which one looks good? This one looks pretty good to do. This is a 6th thing, but I want to make sure you guys just have the basic understanding. Here's this one looks kind of complicated. Oh, why did that? Okay. Make this smaller. Oh, itty bitty. Try doing this. That'll do. Sorry. Thank you for your patience. And that'll do the trick. Yeah, now it's big again. All right, so we have this set, right? Our GTR was our original, and BZP is the final. So you can tell that if I need to at least reorient it, okay? And I think that rotation, we're just gotta focus on. Go ahead and get rid of the stuff I want to ignore here. My digital patty paper. Okay, let's see if I rotate this at all, if I can match GTR, or if I can match the other object. Just to give me a quantifiable or a qualitative idea of what I need to do. Just grab what I need and the arrow from the axis. Okay, all right, let me go ahead and rotate this 90 degrees left. Nope, that's not gonna match. I'm trying to match PBR. It rotated another 90 degrees left. Nope, that's not gonna match. Another 90 degrees left. Nope, not gonna match. So I can't enter another 90 degrees left. No, I'm back to my original. So rotating it all 180 degrees around, it doesn't get me the orientation that I need. So I'm probably gonna have to reflect it. Let me go ahead and reflect this thing. By reflecting it, I mean flipping it horizontally. That's like the reflection. So I flipped it, and now maybe if I rotate it 90 degrees, let's do it the other way. Let's do it the other way. Back reflection. Okay, so I need to reflect it again. Reflect it, flip it vertically. Nope, that's not what I want to do. That would be so this would be reflecting it across the x-axis, across the y-axis. Flip horizontally is flipping it across the the y-axis. Okay, so then I'm gonna rotate it. Let's rotate it clockwise. All right, so there we go. That looks like what I need to do. And then I'm gonna have to move it. I'm gonna have to move it. So there's gonna be a couple translations here, at least 3 translations on this one. So let's get to work. All right, so the first one's gonna be a reflection. I can do reflections pretty easy, right? So I'm gonna just reflect this guy from here to here, just by, I'll go ahead and put the reflection up here versus a reflection. Maybe make this not as big. Maybe 24. Okay, so it's going to be x comma little x comma y arrow. Reflections are always the x's and the y's. X's and the y's stay the same, but one of them changes. In this case, the x changes because we're reflecting across the y-axis, and the y, the distance to the x-axis remains the same. Right, so that is the first one we're going to do, and we're going to make this one blue. Right, so I'm just going to ride the y-axis or the x-axis, no, the y-axis to its opposite point. This one's -2. I'm going to ride it to 2. This one's -4. Ride the y-axis to 4. And then this one's r, -2. Ride it to 2. That is a pretty simple reflection. Go ahead and connect these dots. Enter. Fine. right? And I'm gonna have to rotate this. I'm gonna rotate this clockwise. Clockwise, be this way. So rotation clockwise, I'm gonna have to pull some points. So I'll call this one is G, this one's G, this one's T, and this one's R. Supposed to be G, T, R. G is 4 and -4. T is 2 and -2. P is 2 and -6. -6, and a rotation clockwise is X, comma, Y. And then a clockwise rotation, X's and Y's, it's flop. Y, comma, -X for a rotation clockwise. So we're going to use that -X rotation to find our X's and our Y's. All right, so our X coordinate or Y coordinate, our new X coordinate and our new Y coordinate is going to be pulled from the Y. It's going to be, what is this, 4? What was that for? That was a -3. Oh, I didn't write that down. -3. Okay, so this is going to be a -3, a -2, and a -6. And our Y coordinates are negative, the old X coordinates, -4, -2, and -2. So let's plot those, -3, -4, -3, and -4. That is our new G coordinate. We have -2 and -2. That is our new T coordinate. And we have -6 and -2. And that is our new R coordinate. We'll connect those with the green line. Then we'll find our deltas. I'll line up T to B here. Our delta X is 2 over. So our delta X here, delta X is +2, because it's got to go over 2 to meet up with B on the B axis. And then to get down to B is going to be 2 as well. Delta Y is -2 though, it's got to go down 2. Right, and then same with C. It's got to go over 2, on 2, and then down 2. Same thing with R, over 2, down 2. So that checks with chart. Okay, so our final transformation is X comma Y goes to X plus 2 comma X, Y minus 2. All right, so I hope that helps out everybody. There's some more on here. I'll go ahead and post them right now if you want some extra help or extra practice. Here's the one. There's the one. I'll put on there 5, 4, 3, 2, 1. Okay, and then here's the one more. Here's one more. In case you need a little bit more help, more practice. Here's 5, 4, 3, 2, 1. All right, well, I hope you guys understand. If you don't, please let me know. And I hope you guys learn from my mistakes so that you don't make them the same ones. All right, where did my thing go? There it is. All right. You guys have a wonderful rest of your day. Please ask me if you have any more mistakes or if you have any more questions in class, or you can message me. See you later. Bye.